Okay, let's talk about logarithms, and one of the first things we need to be able to do is to see the relationship between exponential functions and logarithmic functions, or exponential equations and logarithmic equations. And so you can take any logarithm and you can rewrite it in exponential form. And in order to do that, I like to use a method I call circling the wagons. All right? Now, first of all, how do you pronounce this? Okay, well, you say log base 7 of 49 equals 2. Okay, log base 7 of 49 equals 2. What is that in exponential form? Well, circle the wagons. It's 7 to the second power equals 49. Okay, do you see that? You start with the base, you go out there to the whatever is being equaled, and then you come to that of number last. All right? How would we do this one? Well, let's circle the wagons. 16 to the 1/2 equals 4. Well, that makes sense because the 1/2 power is the square root. Isn't the square root of 16 4? Sure it is. Okay? So you can change any logarithm to exponential. All right? Just by using that little circle the wagons deal. Okay? So let's use that then to help us evaluate, all right? What is log base 9 of 81? Well, if I circle the wagons, that would be 9 to the x equals 81. Oh, I know what x is. It's 2, okay? So we can use that idea of exponential functions to help us solve these, all right? Same thing here. 4, circle the wagons, 4 to the x equals 2. Well, what do you have to do to 4 to get to 2? You have to take the square root, right? And so that's a 1/2 power. And so x equals 1/2, right? So you can solve these without calculators by using what you know about logarithmic and exponential. You can also use a calculator, okay? And this ln's, we don't always just use logarithm. Sometimes we use ln, which is called the natural log. And there's a button on your calculator that says natural log. And then I'm just going to put, you can make the square root sign if you want to with the second function and put the 5 in there. Hit enter, and it's going to tell you that that comes out to be 0.8047. All right, so that can be done with a calculator. Find the inverse. Okay, find the inverse. Well, I'm going to kind of rewrite this real quick. All right, I'm going to use my circle the wagons trait. So log base 5 of x equaling y. If I put that into exponential form, it would be 5 to the y equals x, right? Okay, but it says I want the inverse of this. Well, how do you find the inverse of something? You switch the x and the y, and you solve for y, which is already done. And so this is the inverse of this. All right? Finding an inverse. Convert it to exponential form, and then flip the x and the y, or switch places. All right? And then graphing a logarithm. Well, if I have my graphing calculator, I'm going to literally, I want to put this in there, and I want to see what, I can't graph a log base 3, so I'm just going to graph log base x. And I'm going to see what it looks like. All right? And so what we find out is the logarithm is a kind of a graph that's going to look like this. All right? And depending upon whether I add things or put things in here, you know, this can move up or down or right or left, but that's your general, all right, general shape. Okay? And so we can start to do more with that if you start to make some, well, let's take if log base 3 of x equals y. Let's put this in exponential function, all right? Do circle the wagons. It's 3 to the y equals x. And so let's make an xy chart. What if you put 0 in for x? What's 3 to the 0 power? Well, that'd be 1, wouldn't it? What if you put 1 in for x? That's 3 to the first power. So now you know that this is going to have 0, 1. All right, that's 0, 1. And 0, 1 is right there. I'm sorry. All right. And it's going to have 1, 3, which is going to be, this is not a point, 1, 3 up here. And so you're going to start to get stuff like this. Okay. All right. That's what's happening. So check that out. Should help you get through those.